Oh, amazing. Good day, everyone. Today, I am so excited to share with you integrating experiment that demonstrates a fascinating phenomenon as instant ice, like that, right? So this experiment will not show you a cook trick, but also introduce you to some fundamental principles of physics and chemistry. So let's dive into the world water, where water defies our unusual usual expectations and transforms into ice right before our eyes. So, for our first demonstration, we gently tapped a cooled water bottle. The sudden impact should initiate a crystallization like this. Can you see it? Like this, causing the water to freeze rapidly. Next, we introduce a small ice crystal into another cooler water bottle. This acts as a seed for ice formation, encouraging the liquid water to crystallize around it. I'm gonna show you. 1 second, please. 뭐?
소주.
어?
소주.
아니 두 번째 실험은 넣는 거라니까. 얼음을 하나 새 거 줘. 새 거 줘야 된다. 안 흔든 거. 그거 열고 얼음을 넣어야 돼.
아까
이렇게 10, too big. Wow. It is too big. Hold on. Oh, can you see it? Yes. I will bring another. Oh, you can see it, right? Yes. Finally, we pour the cooled water onto a piece of ice, and this should create a visually stunning effect as the water freezes upon contact, forming ice from the bottom up. Okay, can you see? Wow. Ooh.
계속 먹어요.
Ooh. This is so amazing. Wow. In our observations, we noticed varying degree of success across the method. Tapping the bottle resulted in immediate ice formation, showcase how a simple action can trigger a rapid phase change. Introducing an ice crystal provide a clear starting point for crystallization, allowing us to observe the speed of ice through the liquid. Pouring the water onto ice offered a unique perspective on how ice forms, illustrating the beauty of crystal growth in real time. These demonstrations highlight the principle of spur cooling and the importance of nucleation size in the phase change process. Spur cooling occurs when a liquid is cooled below its freezing point without solidifying, a delicate balance that can be disrupted to induce freezing. Nucleation sites, whether introduced by tapping, adding an ice crystal, or pouring onto ice, provide the necessary structure for ice crystals to form rapidly. In conclusion, the instant ice experiment not only offers a visually captivating demonstration but also sheds light on the intricate behaviors of water under specific conditions. Through this experiment, we have explored the concept of spark cooling and nucleation, gaining insight into the delicate balance that dictates phase changes. This phenomenon has further implications from the natural formation of ice in the environment to technological applications in freezing and preservation. Like that. Oh, like that. Thank you guys. Bye.
Hi everyone. Today I am so excited to share with you integrating experiment that demonstrates a fascinating phenomenon known as instant ice. This experiment will not only show you a cool trick but also introduce you to some fundamental principles of physics and chemistry. So let's dive into the world where water defies our usual expectations and transforms into ice right before our eyes. To begin, we prepared this experiment by placing purified water bottles in a freezer. The key here is to cool the water just below its freezing point without actually freezing it. A state known as spark cooling, our goal is to trigger this super cold water to freeze instantly by introducing a disturbance. We will attempt this through 3 different methods, and we expect to see the water turn to ice almost immediately upon triggering. This experiment allows us to explore fundamental principles of physics such as state changes, spark cooling, and nucleation through a real-life example. So we need several plastic bottles of purified or distilled water, freezer, timer, or clock. Optionally, a refrigerator thermometer. So we want to preparation. Place the water bottle in the freezer, ensuring there is a space between them to avoid affecting the cooling process. Second, cooling. Leave the water bottles in the freezers for about 2 hours and 30 minutes. Actually, I add 10 minutes, so totally our time is 2 hours and 40 minutes. The exact time may vary depending on your freezer's temperature. Third, inspection. Carefully remove a water bottle from a freezer to check if it is in a super-cooled state. The water should still be liquid when slightly shaken. Fourth, lastly, creating instant ice. Choose one of the 3 methods to trigger the phase change from super-cooled water to ice. Slightly tap the water bottle. Second, introduce a small piece of ice into the bottle. Third method is pour water over the super-cooled water bottle. So we need to check these scientific principles. First one is a spark cooling, the process by which water cools below its freezing point without becoming solid. Second is nucleation, referred to the initial stage in the formation of ice, where small ice crystals nuclei must form before water can transition to ice. Third, instant ice formation, providing a physics shock or introducing ice crystals to super-cooled water accelerates nucleation, causing the water to liquidly freeze. So, in the experiment, our 3 methods successfully triggered the instant of spur cooled water into ice through the speed of ice formation verified method. The instant ice experiment demonstrated the fascinating phenomenon of spur cooling and nucleation. By spur cooling, purified water below its freezing point without it turning into ice, and then initiating the freezing process through the nucleation. We were able to instantly transform the water into ice. The experiment highlights the delicate balance of conditions required for spur cooling as well as the role of the nucleation sites into the formation of ice. It offers a practical demonstration of phase change, a fundamental concept in physics and chemistry. That's it. I'm going to show you guys